looking at domain and range, and domain is a list. It's what mathematics we call a set. So it's the set of first coordinates. So the first coordinate, and this has to do with graphs, is usually the x value. So it's in an ordered pair, so like x, comma, y in brackets. Usually that's how we write a singular point. But the domain is particularly about the set of first coordinates. Usually that's the x's. So range is also a set. It's the set of second coordinates. Usually that's the y values. Or another way we think of this is the domain has to do with the independent variable and the range has to do with the dependent variable. So this is usually our y's. If we had something that was a function, say like height, with height and time in it, then time would be our independent variable, so that'd be our domain, and height would depend on time, and that'd be our dependent variable. That would be what our range is describing. So let's look at some graphs and look at how we write out the domain and range of different graphs. So first we're going to look at this. This is a parabola. It's probably a shape you're familiar with. And there's a few things we need to learn about notation-wise on how we would write out the domain. So it says that the domain is a set. And in mathematics, we have what's called set notation. And to write a set, which is essentially just a set of, it's just kind of like a list of numbers. And if this is going to be a list of all the x values, there's a lot of them, right? So like if we think like, oh, well, x can be 0, could be, 1, could be 2. But it could also be like 1.5. The graph exists when x is 1.5. It could be like 1.2. Sorry, I guess 1.5 is over here. Like 1.2. It could be like 0.5. It could be -3, which is like off our graph here. But this graph keeps going and going and going. So if it could be any of those values, we don't want to write those all out. So we could just say like, oh, x could be 1, 2, 3, 4, etc. But there's just too many things to write down. So first we're going to start with set notation. And to do that, we use these braces. These are like squiggly brackets. We're going to say x, it can be any real number. And to write that, mathematically, we're going to use a few math symbols. So this is one. It's an E with like a curvy capital E, kind of like. And we're going to use this. And this is an R, capital R, with 2 back sticks. And these, so this, to us, it's saying x can be anything. Okay. That's what it says to us. We don't need to write this blue part in our final answers. Well, I guess the whole thing's blue. Don't need to write the second part in our final answers, but that's what it's saying. X can be any number. Now, how we would actually read this mathematically, it's x is an element. That's what this E thing stands for, is an element of real numbers. Sometimes we would also say x is an element of the reals. So real numbers are any number that we know of. So plus, positives, negatives, 0, decimals, rational numbers, numbers that can be written as fractions, irrational numbers like pi that cannot be written as a fraction. All of those things, those are all real numbers. Okay, so our graph here exists at all of those x values, right? So there'd be a red graph for any x value. If I went over to like X is a billion, way over to the right of our graph, you know, way, 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 way up, we would still have a graph. But what about our range? So our range is for the y values, and we'll notice that not all the y values have graph. For example, all these ones up here do. So, you know, when y is 1, we have a graph. We actually have 2 parts of our graph there. When y is 2, when y is 3. What about when y is, say, -1? Well, that'd be down here, and there's no graph. So not every value of y has a graph. So our graph isn't represented on every value of y. So it can be any number bigger than 0 or equal to 0, because it does go through 0 down here. So to write that, we do the same thing. We write our set notation. Say y is an element of the reals because it can be anything, including all those decimals, all those fractions, all that stuff, but it has to be positive. So we'll write a comma and say that y is greater than or equal to 0. Okay, so we could say y could be anything bigger to or equal to 0, or y is an element of the reals where y is greater than or equal to 0. All right, let's look at another example here. So here we have a bit of a weird graph. And this shape is a shape that we aren't necessarily familiar with. We'll be familiar with it by the end of the course. We'll learn more about it. And this is a sinusoidal wave. So what that means, and it's not super obvious from this graph, that's why I'm describing it to you, is that this is a repeating shape. It repeats and repeats and repeats and repeats. So these arrows don't mean that it keeps going down and down and down for this shape of graph. It's just indicating that it continues. So if we think about the domain, once again, it looks like it could be anything, right? If this graph repeats to the right forever, every x value will have graph. To the left and to the right. So we could write x can be anything. X is an element of the real numbers. Okay. What about our y values? So our y values, it looks like we have y values at 0. Our graph exists at, say, 1 and 2, but then it stops. And below, it goes 0, y is at 0, -1, -2, but then it doesn't exist, say, at -3. There's no graph at -3 for y. So our graph is contained within the y values of between -2 and +2. So there's a bit of a trick on how we can write that. Okay. So let's see that. So we'd say y is an element of the real numbers. And instead of writing y is bigger, so we have to kind of write an upper bound and a lower bound, or however you want to think about it. So, right, if I just write y has to be bigger than -2, then it could be all the way up here. It could be all the positive numbers. So I have to write them both, and there's a bit of a trick to writing them both. So what we do is we always start with the most negative number, or if we're thinking of the number line, the leftmost number. So we're going to say -2 is less than or equal to y, which is less than or equal to 2. And we'll close our brace. So this is a bit of a trickier way to write it, but it condenses everything into one section. And basically, it says y is between these two numbers, between -2 and 2. And we can kind of look at it in two ways. So if we look at, I'm going to erase these boxes in a second. If we look at just this part, it's kind of confusing if we read -2 is less than or equal to y. If we read it in reverse, I think it's easier to see what it says. It says y is greater than or equal to -2, which is true. And then this side says y is less than or equal to 2. All these numbers are always between -2. All the y values have to be between -2 and 2. So this is a way we can write kind of a container, an upper or a lower limit and an upper limit for our y values, or we could do it for our x values, as we have to do for the next example. So here, x can once again be anything. Oh, X can be any number, but it can't be, it can be any number between negative, what is that? 1, negative 1, negative 2, negative 3, negative 4, and positive 4. So we'll write the same way we did it before. So negative 4 is less than or equal to X, less than or equal to 4. That says that X has to be between these two numbers. And our Y values look similar. So this is a circle centered on the origin. So its lowest limit is negative 4 and its upper limit is positive 4. Y is an element of the real numbers, because it could be any number in between there. Negative 4 is less than or equal to Y, less than or equal to 4. All right. That is it for the domain and range lesson.